Gonna look at the 2008 free response questions. So the first question that year dealt with another user-defined class. There's two parts to it. First, there was a time class. We don't know much about this class other than there's one method. This method is called minutes until. If you give it two time references, it'll tell you how far apart they are. Do not concern yourself with how this method works. We don't know. We don't care. We just know that if we call this method on a time object, since it's in the time class, and we hand it a second time object, it'll tell us how many minutes from the first time until the second time, and it returns it as an int. So if you gave it 1 p.m. and 2:15 p.m., and again, we don't care how those times are created, how they put p.m. in there, how they distinguish between hours and minutes. I don't care. But if you gave me two time objects and I handed them to this method, it would come back as 75. If I gave it 10:30 a.m. and 2:15 p.m., that's going to give me 90 plus 75, 165. I don't know how it's going to do it. I don't care. And it's interesting that it comes back positive. This would be kind of the opposite of, say, like strings compare to method. So, but that's okay. That's how they define this method, and we're going to work with it in that aspect. Okay, and I think it's, if you think of the word until, it kind of makes sense. Now, there's another user-defined class called flight. And again, I don't really know much about a flight, but apparently a flight has two times associated with it. It's got a departure time and an arrival time. If you hand me a flight, I can ask for either of those two. We have an array list then of flights called flights. And we're going to do two things in a class that has this array list. We're going to get the duration of some sort of flights sequence that's put into this array list. It's the number of minutes from the departure of the first flight. Okay, so the first flight, these flights are stored in chronological order. So the first flight would be the 0 index flight until the arrival of the last flight. That would be the flight at size minus 1. So flights.get size minus 1 gives me the last flight. And remember, once you have a flight, you can ask for its departure time or its arrival time. So for the 0 index, I'll get the departure time. At index size minus 1, I'll get the arrival time. And once I have those two times, I can put them into the minutes until method seen here. Okay, so you could do this in one line of code if you wanted to. It'd be a messy line of code, and I don't know that I really recommend it, but you could. Another approach would be to sort of break it down through maybe like 5 lines of code. So for example, I could say like flight A equals, now remember what I was saying, this first flight would be the get 0 flight. Okay, so that's our initial departure flight. Okay, and then we could say flight B equals, and we could say flights dot get flights dot size minus 1. Okay, so these are our first and last flights. Every flight has two times associated with it. For each of these flights, though, I actually only want one of their two times. So my first time, I'll call it start. And for this time, I'm going to take the departure time of the original flight. So if I have a flight reference and I ask for its departure, okay, so again, this is a flight method, get departure time. That's what I was checking, okay? So get departure time. Now I know when that first flight leaves, okay? And I'll get another one here. I'll call it end. And this would be the arrival time of that second flight object. So get arrival time. All right. And now if I have two time objects, okay, recall in the time class, there's a method called minutes until. So if you give me a time, I can call on that time the minutes until method. The one requirement of me is that I provide a second time as an argument. And this would now do the subtraction and come back. Now there's one catch to this. It says 0 if there are no flights in the trip. And if we go double check with that minutes until method, there's nothing really built into that. And in fact, I think we'd go out of bounds if there weren't any flights in this trip. So we're going to have to put in some sort of protection against that out of bounds. If this flights array list was size 0, no flights in the trip, I'd go out of bounds at either of those two get statements. So prior to all of this taking place, we need to protect ourselves. We need to ask if flights.size is 0, and if it is, we are going to return 0. If we make it past that protection, then we can go ahead and get flight 0. This would not go out of bounds, right? Even at size 1, if there was only one flight, this would be okay. If there's only one flight, then there's just it's the same flight for the first and for the last. Okay, and so if we go ahead and test out part A with a few get duration calls, we see that, yeah, part A is working just like we had hoped it would. Okay, now in part B, we're going to look at a flight's layover times, and we're going to try to find the shortest layover, the minimum. Now, a layover happens when you have, say, 2 flights or more. So from flight A, you take off maybe in Los Angeles and you land in Chicago at 2 o'clock. But you're actually flying to New York and you leave for New York at 3 o'clock and you get there at 5. The layover was from 2 to 3. So it's when that first flight arrived until the second flight departed. So we're going to need to sort of search between the 2 flights. So maybe between flight index 0 and 1. If there's more flights, maybe between flight index 1 and 2, 2 and 3, and so on. So we'll be looking at successive flights within the array list called flights. We'll be getting these layovers, and we're looking for the smallest. Now, if I fly from Los Angeles to New York nonstop, meaning one flight, then there are no layovers. So it takes 2 or more flights to produce a layover. So that would probably be the first thing that I would address in part B. If flights.size is 1, okay, or 0, we better allow for either. So less than or equal to 1, then we have a special return, -1. That means that there's no layover at all. Okay, if that doesn't happen, now we can proceed with our code. In fact, what I would probably do is I would set up a temporary minimum. So my temporary minimum, what I'll do is I'll go to flights.get0. Okay, that's a flight. And if I got its arrival time, okay, and then that is now a time reference, I could then say, well, okay, well, tell me about the minutes until, and I would go into flights again, and I would get the flight at index 1, and I would get its departure time. Okay, this is a layover. Now, I have no reason to think that this is the shortest of all of my layovers, but maybe it is, okay? I'm going to run a loop and produce all of the remaining layovers to decide if there's one that is shorter. Now, that was a pretty weird line of code that I wrote. I avoided doing that in part A, you'll recall, by making some flights and some time references along the way. There's really no advantage to writing this out in one line of code. I just kind of wanted to show you what it would look like, okay? So if that confuses you, go back and change it to make it look a little bit more like I did in part A. All right, now I need to write a loop that would go to all of the remaining flight indexes. There may not be any, but I would maybe go ahead and start this loop at, say, index 2. Now, if there is no index 2 in my array list, then this loop's never going to run. So don't worry about it. I mean, the control expression is going to take care of that for you. We'll say less than flights.size, and we'll go to I++. Part of the reason I started at index 2 is that's going to let me backtrack 1 and pick up where my last departure left. Remember, we were looking at the departure of flight 1? Well, my next layover will be created from the the arrival of flight 1 compared to the departure of flight 2. Okay, so I could make a line of code exactly like this. And in this line of code, I can't call it min because I've already used min. So maybe I'll just call this one layover. Okay. And I don't want to compare like a hard 0 to a hard 1. I don't want to compare a hard 1 to a hard 2. But what I want to do is, since I'm starting my index at 2, I'm going to backtrack to I minus 1. That would be like flight 1, right where I left off. So that flight's arrival compared to flight I. So the first time in my loop, this is going to be flight 1 versus flight 2. If there's more flights, I'm going to go 2 to 3, 3 to 4, and so on until I run out of flights. And I should never go out of bounds. I didn't try to progress to +1. Starting at 2, I can safely backtrack 1. And again, if there's not more flights than say 2 or 3, then my loop's not even going to run anyway. So this is not a big deal. Okay. If this layover turns out to be smaller than my predetermined minimum, well, that means that my minimum is wrong, and I'll update it to this new int value that I just found. And if everything goes well, if we make every comparison and give every flight layover a chance, then we should find the shortest one. So I fed the tester 3 cases, 15, -1, 55. These are all coming out correct. And that -1 was showing up when there wasn't actually a layover like we were supposed to handle. Okay, like I said, you do not have to write some big strung together sequence like that. You can break it down. Maybe you break it down to 2 time objects or 2 flights and 2 times like I did in part A. You could go through those same exact steps here. Okay. But again, this is hopefully you're starting to see now. Almost every year we're going to see a problem like this with user defined classes, objects that are put into a list or potentially an array. We have to read these classes on the fly, figure out what they can do, what they're capable of. We might even see a constructor where we have to construct a time object or a flight object in another problem, use the word new. But this is a real common theme for an AP question. If you didn't know that, now you do.